The last video introduced the idea of quantification, which is what happens when we take a predicate whose truth value can't be determined because of a variable, and then making a claim about whether the predicate is always true or sometimes true. Since quantified predicates are propositions, we can negate them, and in this video we're going to see how this is done. Take a look at the universally quantified predicates from the last video that were false. How did we know they were false? For example, why was for all strings x, the length of x is positive, false? Well, it was because we found a single example of a string that showed us that not all strings have a positive length. That's called a counterexample, an example that proves a universally quantified statement is false. Universally quantified statements can be shown to be false by producing just one counterexample. We can phrase this fact using negations. If you take the universally quantified statement for all x p of x and negate it, it's a claim that p of x is not universally true or not always true. What does it mean when a statement is not always true? It doesn't mean that the statement is always false. For example, the statement all cars are red is not true. But this doesn't mean that no cars are red, that no red cars exist. It just means that not all cars are red, or that there are cars that exist and are not red. So when a universally quantified statement, something of the form for all x p of x, is negated, we're saying that p of x is sometimes false. Or put differently, there exists an x that makes the negation of p of x true. We can put that in notation by saying the negation of for all x p of x is there exists an x such that not p of x. So the negation of a universally quantified predicate is the existential quantification of the predicate's negation. Likewise, look at the existentially quantified predicates that are false, like the one you did in the last video, s of x is the absolute value of x is negative. If we existentially quantify that predicate to get there exists an x such that the absolute value of x is negative, that's a false statement because we know from basic math that the absolute value of x is never negative. That is, the absolute value of x is always 0 or positive. This sounds like a universal statement, doesn't it? In fact, what we see from this example is that the negation of there exists an x such that p of x is for all x not p of x. So negating an existentially quantified statement gives us the universal quantification of the negation. Here's one more example to put it all together. Look at the predicate c of x, where the domain is the set of all countries on Earth, and c of x is the predicate, the first letter of the country x is b. Pause the video while you do the following. First, write out in English, or whatever language you prefer, what the statements for all x c of x and there exists an x such that c of x would say in plain language. Then determine whether those statements are true or whether they are false. Then write out their negations in plain language and determine whether those are true or false. Come on back here when you are ready. The universally quantified statement would say that every country on Earth begins with the letter B. The existentially quantified statement would say that at least one country on Earth begins with the letter B. There are other possible ways to say either of these, but when you put it this way, it's clear that for all x c of x is false, again, because there are lots of counterexamples possible, for example, the country France. And there exists x such that c of x is true, because there do exist countries beginning with a B, like Belize or Belarus. The negation of for all x c of x would be there exists x such that not c of x, which in plainer language would be there exists a country whose name doesn't begin with a B. And that's certainly true. In fact, the statement is just saying that it's possible to find a counterexample to the original universal statement. The negation of there exists an x such that c of x is the universal statement for all x not c of x. Or in other words, for every country on Earth, the name of the country does not begin with a B. Now that is a false statement, and we know it because that's a universal statement, but there's a counterexample, Belize or Belarus. This makes sense because the negation of a proposition should have the opposite truth value. The universal statement was false, so its negation should be true, and the existential statement was true, so its negation should be false. So you've learned in this video that the negation of a universally quantified statement is an existentially quantified statement using the negation of the original predicate. And likewise, the negation of an existentially quantified statement is a universally quantified statement using the negation of the original predicate. There's just one more topic to touch on in this module on logic, and that's how quantification works when you have more than one variable in your predicate, so stick around.